Welcome back, everybody. This is our second session in NEET previous year questions for chapter Magnetism and Matter of class 12th. Before this video, we have made one video for this chapter in this series, and that video is available on our channel's playlist section. We have also started a similar series for JEE mains. So if some of your friends are preparing for JEE or you want some additional practice, then you can try those questions also. And all the related videos are available in the playlist section of the channel. If you find these videos useful, then do press the like button, share them, and subscribe to our channel. Also, if you want to support us financially, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Any amount of help will be highly appreciated. With this, let's start today's video. In the previous one, we completed around question up to question number 10. This was the last question, I think. Now let's move to the next one. Here, two identical bar magnets are fixed with their center at a distance d apart. A stationary charge Q is placed at P between the gap of the two magnets at distance d from the center of the shown in the figure, the force on the charge. Now we know that force on a charge is given by this formula, that is Q V cross P. Now, as charge is stationary, mentioned charge is stationary means velocity is zero, and if velocity is zero, then force will be zero. And if we have a certain velocity of the charge here, then we have to find the value of magnetic field. And while finding the value of magnetic field, you will notice that direction of magnetic field due to both of the magnets here will be in the opposite direction. From this it will have like this, and from this magnet it will be like this. So value of magnetic field also will be zero, even though if we have a certain velocity of the, we can say, electron here or charge particle here, value of magnetic field will be zero. So again force will be zero. Let's move to the next one. Bar magnet having magnetic moment is free to rotate in a horizontal plane. A horizontal magnetic field is this exists in the space. The work done in taking magnet slowly from direction parallel to the field to 60 degree of the field. So initially magnet is parallel to the field means angle between M and B initially is 0 degree, that is initial angle, and final angle is 60 degree. So will be work done is equal to change in potential energy, that will be potential energy final minus potential energy initial. Potential energy final will be minus mb cos of 60, and initial potential energy will be minus mb cos of 0. So cos 60 is half, so minus mb by 2, minus minus plus, and cos 0 is 1, so it is mb. So we will be left with mb by 2. So substituting the values, value of m is 2 into 10 raised to power 4, and b is 6 into 10 raised to power minus 4 divided by 2. We will get 6 joules. That is option C. Let's move to next one. A bar magnet of magnetic moment M is placed in the magnetic field of induction B. So torque on the magnet is given by M cross B, option C. Next one, a iron rod of susceptibility 5999 is subjected to magnetic field. So value of B is given, mu naught is given. Permeability of the material of the magnet we have to find out. So susceptibility means we have been given value of xi, that is 5999, and value of B is also given, magnetizing field. Now we know that mu r is equal to 1 plus psi. So it will be 600. And from this, what we can do? We can find the value of mu, as mu r is equal to mu of the material by mu epsilon mu node, and that is equal to 600. So from this, mu is mu node times 600, that is 4 pi 10 raised to power minus 7 into 600. So 24 pi into 10 raised to power minus 5, or we can say 2.4 pi into 10 raised to power minus 4. Option D will be the right answer. Now let's move to next one. The incorrect relation for a diamagnetic material, all symbols carries their usual meaning and epsilon is small positive number. Now we have a diamagnetic material, means they are repelled by the magnetic field and their susceptibility lies is less than 0 and greater than minus 1. And we also have a relation that mu r is equal to 1 plus xi. So limit for xi mu r will be 0, 1, oh sorry, 0 mu r to 1. So we have to find the incorrect relation here, that which one is incorrect. So B, we can see that B is okay, C is also okay, and mu is here will be less than mu node, so it is also okay. Option D, where mu r is greater than 1, where as mentioned in the question that epsilon is small positive number, so if we add something into 1, so it will be greater than 1. And so this option D will be the wrong one here, or option D is the right answer. Let's move to the next one. So we have to match. Now, as already discussed, for that, for the diamagnetic material, xi is less than 0 and greater than minus 1, so diamagnetic should match with the option 2. Now after that, we can say non-magnetic materials. For non-magnetic material, xi will be 0. Then we have paramagnetic material. For them, xi will be slightly greater than 0, so paramagnetic will match with 4 and ferromagnetic will match with 3. So A with 2, B with 3, and C with 4. So option D here will be the right answer. Next question. The magnetic moment of a diamagnetic atom. So we have to find magnetic moment for a diamagnetic atom, and we know that those diamagnetic materials are feebly repelled, and their electron exist in pair, so their magnetic moment cancel each other, so it is equal to 0. In case of, we can say, paramagnetic material, uh, let's rewind this, that in case of diamagnetic material, we have electron in pairs. In paramagnetic, we have free electrons, and in ferromagnetic we have collection of free electrons, means these free electrons forms some clusters, and these clusters provide us large value of magnetic fields. So in diamagnetics, their fields gets cancelled out. In paramagnetic, we do have some value of dipole moment, and in ferromagnetic, all the dipole moments align in a particular direction. So for this, option D will be the answer, as in pairs they cancel each other. A thin diamagnetic rod is placed vertically between the poles of an electromagnet. When the current in the electromagnet is switched on, the diamagnetic rod is pushed up out of the horizontal field Hence, the rod gains potential energy. The work required to do this comes from. So we have to find out that from where that work is came. And the option are lattice structure, magnetic field, current source, and the induced current due to the changing fields. Now we know that diamagnetic material will be repelled, and that repulsion happens due to magnetic field. So whatever the work is done, whatever the force is applied is due to magnetic field, and that magnetic field is produced due to current source. So actual answer here will be the current source, because that magnetic field is there due to that current source, as it is a electromagnet. So let's now move to next question. Magnetic susceptibility is negative for, so we already discussed it, that susceptibility is negative for diamagnetic materials. So option D will be the right answer here. Let's move to next one. There are four weight rod samples X, Y, Z, W respectively by thread. Now X is feebly repelled, so it is a diamagnetic material. Y is feebly attracted, means it is paramagnetic. Strongly attracted means ferromagnetic, and remains unaffected means non-magnetic. So Z is diamagnetic. No, Z is ferromagnetic. So it is wrong. W is ferromagnetic. W is non-magnetic. So it is wrong. X is non-magnetic. X is diamagnetic here. So it is wrong. Y is paramagnetic. So Y is paramagnetic. So option D will be the right answer here. Let's move to the next one. If a diamagnetic substance is brought near north or south pole of the bar magnet, it is repelled by both of the poles, because in a diamagnetic materials they acquire a opposite a similar field, such that they are getting repelled due to we can say inside eddy currents, so repelled by the both sides. Curie temperature is the temperature above which ferromagnetic materials becomes paramagnetic material, and further para becomes to diamagnetic material. So next one, nickel shows ferromagnetic property at room temperature. If the temperature increases beyond Curie, it will show paramagnetism. Option D, just as per the previous question. If a magnetic dipole of an atom of diamagnetic material, paramagnetic material, and ferromagnetic are denoted by these values, so we have two magnetic dipole moment, and we know magnetic dipole moment for a diamagnetic material is zero. So mu d is zero, and for para it is non-zero, and for ferro it is also non-zero. So which of the option matches? Here mu d is non-zero, so B is wrong, D is wrong. Here mu f is zero, mu p is zero, mu p is non-zero, so it is also wrong. So mu d is zero and mu p non-zero. Option A fits the criteria. A diamagnetic material in a magnetic field moves from stronger parts to the weaker part of the field because it is getting repelled. So option A will be the right answer. According to Curie's law, magnetic susceptibility of a substance at absolute temperature T is proportional to, that is 1 by T. So option A. In which type of material magnetic susceptibility does not depend upon the temperature? And these are the diamagnetic materials, because their susceptibility is almost zero. Next one, diamagnetic substance brought near a strong magnet. If it is brought near a strong magnet, then it will be repelled by the magnet. So option B. And the last one in this For protecting sensitive equipment for external magnetic field, it should be placed inside aluminium, iron, insulating around when passing current, surrounded by a copper sheet. Now, in these type of questions, students might assume that to protect sensitive equipment from any magnetic field, we should place them in a diamagnetic material, inside a diamagnetic material, as these materials uh, tend to oppose the magnetic field by inducing opposite magnetic field in the similar magnetic field inside them. But that's not the right answer here. The right answer is we place them in a highly magnetic material or like ferromagnetic material. So what happens? Let's suppose we have a highly magnetic material. Suppose this is the rod we have and it is highly made of highly magnetic material from its surface. Now we make some cavity inside it and we place our instrument here. Now what happens? And suppose it is a very thick material. So let me make it slightly thicker. It is hollow inside and very thick. Hollow inside and very thick material. Now what happens? Suppose there are some magnetic field lines are coming. These are magnetic field lines. Now, when reaching this near to this material, these magnetic field lines have two paths. One, either they go from this blue material or the highly magnetic material, or they go from the vacant space or the air. Now we know it will be easy for magnetic field lines to flow through highly magnetic material or to propagate through highly magnetic material. So what happens here, that all the magnetic fields enters through the highly magnetic material and only very small amount of field is able to pass through the empty space. So that's how the magnetic field is getting confined through the this metal or this highly magnetic material only, and on in the remaining space there is very small amount of magnetic field left. So that's how we protect the sensitive instrument from the magnetic field. That is done with the help of, we can say, guiding the magnetic field or diverting the magnetic field through a highly magnetic material so that it can move more easily through that material, and using this property we can divert the magnetic field. So here option C will be the right answer as, sorry, not option C, option B, placed inside a iron can. And it is necessary that material should be hollow from the inside. It should be hollow from the inside, and outside it should be a thicker material, so that magnetic field pass through the thicker part, and in the hollow part we have very small amount of magnetic field. So option B will be the right answer here. And with this chapter is complete. Again, if you have doubts or suggestion, you can put them in comment section. I will try to answer them. And if you find this video useful, helpful, then do press the like button, share it, and subscribe to our channel. Also, if you want to support us financially, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Any amount of help will be highly appreciated. With this, again, thanks for watching, and we will meet in next video.